Hello. Welcome to the second most important person speaking about Crow on this conference. The other one is Jacob. He's one of the maintainers. He's going to talk about a little bit more about the internals tomorrow. So let's get started. Who am I? My name is Benjamin Ritter. I currently work as a cloud native engineer. Previously, I did some consulting. I'm currently also doing consulting, but I'm working on the second cloud in my career right now. Right now, I'm building MetalStack and the cloud provider MetalStack Cloud at Excellent Technologies. So what is MetalStack? It's our Metal as a service. It's an open source project. You can check it out on GitHub. You give it commodity servers and switches running the Sonic network operating systems, and it gives you an infrastructure as a service provider. And we also natively support Kubernetes as well, like Kubernetes as a service using Gardener and Cluster API. You get a nice API, Terraform provider, all the goodies. And it also is what powers, basically the upstream stuff powers our MetalStack cloud, managed cloud provider. Okay, cool. There should be something here, one sec. It always fails, I'm so sorry. This was speaker view. Let's see. Please. Okay, we're going to do it without them. It consists of two components. The one is the control plane. It's a few services and a few databases. It's the thing you interact with when you try to create a server, create a network, create an IP. It's a few services and a few databases. You run it on Kubernetes most of the time, although we are not strictly requiring it, but all of our customers do. The second part is our partition. It's the thing that actually contains the servers. It's mostly bare metal and Sonic switches, so there's no Kubernetes there, so that's not going to be covered in this talk. So yeah, we have 5 databases. For Postgres is one RethinkDB. I guess nobody has heard of that. And NSQ as a message queue, and currently 6 services in Kubernetes. Optionally, we also recommend running a LGTM monitoring stack and a Gardener if you want to do Gardener on Kubernetes. How we deploy it right now, the short answer is Ansible. It's mostly motivated because our partitions, they're bare metal. We don't have any other deployment tools there, so we fell back to the smallest common denominator, which is Ansible in our case, and we package our components as Helm chart, and then we wrap it in an Ansible role and deploy it using Ansible. For that, we use a site-specific playbook. An example for that can be found in our demo environment Minilab, which it varies from each customer, but you deploy dependencies, then you deploy some databases, then you deploy more external dependencies that, for example, need like Gateway API, and then you install the Metal Control Helm chart, and then you would install Gardener, for example. It's, again, we don't like have a configurable playbook. We write one for each deployment just because like different customers have different requirements regarding compliance, pre-existing infrastructure, so on, so on. So when I'm talking about like Ansible here, we were exploring like what can we do about this, and we had a few pain points. One of them was concurrency in Ansible when deploying Kubernetes is a little bit of an issue because Ansible doesn't support concurrency on single hosts. So if you have a Kubernetes cluster, which in Ansible is considered a single host, you will only deploy one thing at a time. And if a deployment step takes a while, it will block other deployment steps, although they could run concurrently. Second issue is currently we have our wrapper roles, so we have to duplicate our Helm values into the wrapper roles, which means they're tightly coupled, and if you change one, you basically have to change the other, or you lose schema validation. The third part, I mean, like, we all have fun a little bit shitting on Helm, on the templating. It's string-based templating, so there's no type validation, at least not by default. You can do a little bit with schemas, but at least at the templating, you're on your own. So you have difficulties validating and testing. You basically have to fuzz it to get any like meaningful regression testing or integration testing out of it, which makes day 2 operations harder, because the second part in there is Ansible is a procedural deployment tool, so you say what it should do, and Kubernetes deployment model is declarative. So you have a mismatch there, and stuff like removing old components is an active task instead of just removing the manifest. And also we have stuff like configuration drifts. If somebody messes around with the infrastructure, Ansible might not catch that. If you want to change APIs, it's hard because, again, like no validating in Helm, no proper. If you do migrations, it's also always multiple tasks, multiple steps. Yeah, and you also have to enforce like a whole bunch of like constraints, how you can upgrade, and that just makes the life of the people that operate our software a lot harder. So entering Crow, it's a project, it's part of the Zig cloud provider. It's short for Kube Resource Orchestrator. You define an API schema for the inputs, connect them with CEL expressions for templating, and then Crow generates you a custom resource definition for the kind of stuff you want to reconcile, and then runs a reconciliation loop. The core resource that is exposed to US users is called a resource graph definition. It looks something like this. This is like for a very simple example. You can see the three parts. This is the spec. It's typed. You can do constraints there. You can, I think, even do like CEL based expressions to validate inputs there. It's typed. You can do default values. And then you use CEL to template these resources. You have some meta arguments, for example, include when, which allows you to disable a whole resource that would get deployed already when, that allows you to override when Crow will consider a resource ready to something custom, and that's also a CEL expression. And the third part, that is basically what you in Helm would have in your template files. So yeah, pretty straightforward. Let's quickly talk about CEL though. It's short for Common Expression Language. It's what powers the templating in Crow. It's an embeddable sandboxed, fast-typed, non-Turing complete compiled language. It's not general purpose, so you can't use it to write software. And because of the non-Turing completeness, it is guaranteed to run in bounded time. It enforces strict separation between your expression, which is like, if you speak in Helm terms, your templates and your data. I know like people sometimes write Helm charts where they allow passing in a template as an input argument in Helm charts, which I don't think is the greatest idea, but CEL just can't do that. And I think this is actually a good thing. The typing allows static analysis of the expressions, so you can catch templating errors before they ever hit, like before a single instance of your resource hits your templating. And it's also not something that has been created just for Crow. It's already used for CRD validation. You can, if you write operators, you can use you can use CEL to do what you might do in a an admission webhook. You can do that as part of the API server. And Google Cloud probably uses it as part of their EAM system to allow users, untrusted users, to write roles that run inside of their EAM solution. So what do we have? We have a thing that generates like a CRD from some schema, templates your resources, does like continuous reconciliation. I mean, we've maybe have seen this before. It sounds like crossplane, but like boiled down on the feature set. Helm with typing and a schema, which is like sounds good to me, and also a little bit of workflow orchestration. I didn't talk about this much, but that there's like dependency resolution in there. It's kind of nice. So what is Crow really? And what do the like developers of Crow think they are? I actually am not sure, and they are saying like it's an API facade, mostly used for platform teams, but it also very much looks like a package manager, but they don't explicitly state that it's a package manager. So that's where we at Excellent were like, I mean, getting Helm out of our lives is always a fun ambition. So let's try to use Crow as a packaging format, I guess. Yeah, we're going to package the metal control plane as a Crow package. Let's see how this goes. Yeah, anyway. The important parts are down here. The stuff that doesn't really matter. We have a metal control plane. It deploys these things, which are also resource graph definitions. So we are doing like what we did before in the Ansible role. We just put it in a resource graph definition, and then we wrap around another resource graph definition. Yeah, it looks something like this. This, for example, just for a database. It's in lines of code. It's basically the same as you would have if you would do it via a Helm chart. It's templating, like there's not much to do here. This is, for example, about 300 lines. It's basically the same thing. Did it work? No. Like our first attempt did not yield good results. We were actually not sure if like this is the right tool. But looking into it, like preparing for this talk, we were like, yeah, I don't think so. Let's take another look. Let's see what happened there. So we found a few issues. Some of them were our fault. Some of them were just things that happened architecturally mostly. First of all, like referencing, when doing like this layering thing, referencing the schema of your internal resource graph definitions was not possible. So you either copy paste the schema in if you don't want to like encapsulate it fully, or you just skip validation, which means your resource might apply but not work, which is not great. You have to monitor for it anyway, but like early failure would be nice. Also, the layering would introduce a lot of boilerplate. So yeah, on the third part, we thought there were like template functions missing for like JSON at base 64 and decoding, and like conditional fields were not a thing. But just to be completely clear here, this is not the case. Like Crow supports this and supports it really nicely. It has like a nice big selection of CEL libs included. It's comparable to what you can do with Helm right now. So like JSON, I think even PEM is possible. Like they can do it, and they also have typing in there, which again, it's really nice to have the stuff fail early and not just render out like bullshit YAML that then will not apply. And it also has the omit operator, which allows you to just exclude like single fields, and you can also disable resources as you saw before. So yeah, that one was on us. We missed that the first time around. Yeah. So we tried again. Like I mean, we're in engineering. Like, sometimes the sad reality is the secret to like succeed is just to try harder, and we did. So this time we didn't start with like a wrapper. We just said, nope, we're doing a bottom-up migration. So we're just taking a component, see how that migrates. We completely ignored like the aggregation because that stuff is site-specific. So there's not like much logic going on in there. It's too much surface to cover if you want to make all your customers happy, and then you have a maintenance nightmare on your hands. So that stuff is out of scope for this one. And that stuff will be used in the site-specific stuff. So I migrated our metal control plane hand chart. It's about 1,500 lines of code, and it took like 2 hours. 2 hours, and like the first 10 minutes of that were just saying, Claude, please convert this template to a Crow thing, which actually works quite well because it's a simple task that's very scoped, and the 1 hour and 50 minutes were spent fixing like templating errors and stuff not working properly. Yeah, I mean, if you did it yourself, it would probably end the same way. So it's, I mean, it's funny, but it's really manageable because the primitives are basically the same. Yeah, then I just took this resource graph definition when it worked and just dropped it into a Ansible role that shared the same outside schema and just deployed a resource graph definition instance instead of the Helm chart, and it just worked. It worked. Proof of concept is there. It's a really small diff. Like just one component switched out. Pretty nice. And yeah, so like initial deployment, always great fun. Like if you use like crossplane, it's like a fine wine. You try it, and it's like, oh, it's so much better than Terraform. And then you get to the day 2 operation, and you notice like it will fall apart in basically the same way. Let's see how Crow does there. Breaking changes, they support that since they have a schema. So if you change the schema of your resource graph definition, Crow will detect that if this is a breaking change. So if you change like any field validation types, if you add new fields without a default, it will yell at you. You can override that with an annotation. It's just a very nice thing to see that it is, you can either apply it, you don't have a breaking change, which basically means all of your previously valid inputs for your resource graph definition are still valid. Or if you have to set the annotation, you will have to probably take a second look if all of your resources come up again. Which brings us to versioning. Every time you mutate a resource graph definition, it generates an internal resource. It just compiles it down from CL to an abstract syntax tree. And then it will take all of your instances and apply the new resource graph definition to it. It tries to. This might fail if you're doing a breaking change. Then it will just stop. It will just not apply the new resource version, the new resource graph definition version for that instance, mark the resource as broken, and move on. So you will have to monitor for that, like with any deployment system. And currently there is no versioning of old versions. So there is a revision count, and they will be kept in there, but you cannot reference them. So if you update, you always have like one version across the whole cluster, which is a bit of a problem. But like the Crow team also thinks that. And currently they have a work in progress issue. It's called a mega issue, I think, on their GitHub, where they're discussing how to do versioning, and they clearly share my opinion that that's required. And they also have, I think the name is awesome, in crep21. OCI distribution, which for us as like an infrastructure provider with like air-gapped environments would be very nice, and like rollback and diffing offline for their CLI, which I think will take care of like these points that are currently an issue for me. So will we use Crow to ship Metal Stack? Not yet, but we would really like to, and we might soon when these issues are sorted out. Working with an actually validated templating language was really nice and was really refreshing. Again, migration effort is reasonable, and due to the like reconciliation and better diffing capabilities, it will much improve our day 2 operations. As soon as these two issues like OCI packaging and versioning are handled, we would be really happy to take another look. And the last part we would really like to see, but this is more like a pet peeve of mine, we would really see that if the Crow project wants to be a package manager, we would like to see that in their project statement, because right now they don't, although it very much looks like one. So what should you do? First step is please don't rewrite your deployment into another tool. This is like a whole separate thing. Most of the time, deployment is hard not because the tool is bad, but there is some like systematic problem in how you architected your deployment. We all know like the stuff grows, but it needs refactoring sometimes. For example, modularization is a big part. If your modules are scoped in a like weird shape or have like giant input surfaces, it's really hard to work with every deployment tool. And you will just, if you do like a one-to-one migration, you will basically migrate your pane. And the nice thing about this is, though, if you do these changes, if you refactor your deployment to better suit your deployment flow, that will migrate to your next tool. So if you currently have, for example, I'm taking the example Terraform, and it's a little bit unwieldy to work with, and you have to copy paste a lot of stuff, you're probably better off introducing modules than migrate to crossplane and hope it will fix your issues. The same thing goes for if you're doing Helm right now and you want to do crawl in the future. Take a look if your modules are scoped appropriately, and if not, refactor them before, because otherwise you have two migrations at the same time, and that will be painful. And at the point where you are ready to migrate, you will have to do it gradually, especially if you're doing if you're a software vendor, you will have to provide a transition window where your customers can use both, because they have to get accustomed with the new deployment flow. And to get a smooth transition, you really need to do that slowly. How would this method look for our software, the metal control plane? Our POC already showed our role segmentation and scope for the components is all right. You can work with that. It allows you to not just have to shotgun migrate everything. We also noticed that attempting to aggregate our deployment variants in a generic way is hard if you do not have that much say in how stuff is deployed. For example, if a customer really wants to use a managed database, you would have to explicitly support that. But that is not something you might really want to do in your application deployment. You want to just reference it. On the maintainability side, we found that some of our roles have incredibly big surfaces of inputs, which not only makes them hard to use, but also hard to refactor, because we do not know, we don't have a 30,000 feet perspective of which inputs are even used, because they're used by customers and we don't know what they're deploying necessarily. The next thing we would do is we have some Ansible Ginger templating in there, which was a shortcut of not writing a Helm chart. We might just write a Helm chart for that. And we have some things in our Helm chart that are a little bit from the way we deploy it with Ansible right now. Right now we're using a bunch of secret literals, because right now we're doing with Ansible, Ansible Vault encryption of the deployment. So we just say this is our security model. And by the way, you might make this face about this. It's not ideal, but it's definitely certifiable for C5. And we know that because we've done it. And we have environments that are C5 compliance certified. Our value YAML is also, again, pretty large compared to the features we want to support. So we might just split it up and move out rarely used or optional features into their separate charge. So composability over aggregation. Regarding the deployment speed, we just deployed our Helm charts waiting. So we waited for the Helm chart to completely install, which we can do, but with Ansible that takes 5 to 10 minutes for your control plane to get up, which for testing, that's just annoying. So we're going to just move it to non-waiting Helm deployments and just check in the end if all our components are there, because the check is really cheap and really fast to do. And now we can deploy our stuff all of our control plane components at the same time. And if you want to deploy, for example, the metal control plane as a kettle, if you need multiple of those, we don't see a limit in our design. Just use GitLab pipelines and just deploy it multiple times inside. We don't really see a problem. So should you use Crow for package management? Maybe. It's a little bit early, because it's probably still going through 1 or 2 breaking changes in their resource graph definition resource, but the DX is much improved. If you're doing internal platform work, so your developer team and your platform provider team, they're sitting in the same building or in the same Slack channel, that's probably ready now, because you do not really need the versioning stuff for that. And if you're application vendor like we are, I would honestly wait for packaging and versioning to be fully cooked. Yeah, so that was the technical part. As you might have noticed, I'm not Simon. Simon was the one who originally submitted that talk, but he unfortunately didn't have time for preparing it, so he handed it off to me. So thanks to him, and thanks to Elmar Brunner, a previous intern of ours, who worked on the initial Crow POC and did like the initial research for this talk. If you have questions, you can either ask now, or I'm going to be on the in the Metal Stack cloud booth for a while. Here's also my email if you have other questions. Thank you.
So great talk. Thank you for it. We all want to move away from Helm. I think that's very clear to every one of us. But my question would be, you talked about improved developer experience. So my question would be, how good is the tooling in like an IDE or editor, and how fast can I see which parts do I reference from the resource graph definition and which is correct, which is incorrect? Do I get like syntax highlighting, stuff like that?
Yeah.
And schema validation, I would say.
Since it's a CRD in the end, you will get schema validation in your editor. For example, VS Code has a quite nice integration for custom resource definition, so that just works if you're connected to your cluster. And I'm not quite actually sure how good the CLI and what the status of that is, because I haven't used it for this talk, but there are at least like strong tendencies to do like diffing and offline validation and like planning, basically, which is like Terraform plan equivalent for crawl in their CLI. So developer tooling is already looking quite nice, and like the direction it's taking, I'm really interested what they're going to do there.
Okay, thank you.
All right, then thank you for your time. Have a nice time here.